Welcome back to Math Concepts. We are going to continue our work in logic and talk about how to determine whether an argument is valid. So, in this context, an argument is valid if true premises guarantee a true conclusion. And we're going to use truth tables to help us understand whether an argument is valid. So we're going to write out a truth table that has a column for each of the premises, and we're going to make sure that we have the conclusion in there as well. And then we're going to highlight the rows where the premises are true and fix our attention on those. And then we're going to check to make sure that in each of those rows the conclusion is true. Okay, let's go right to an example and make things clear. Alright, so the key idea from this video is you should be able to use a truth table to find whether an argument is valid. And remember, an argument is valid if true premises guarantee a true conclusion. Okay, now in this example right here, here's the argument I'm working with. My premises are if P, then Q, and Q. If P, then Q, Q. The conclusion is P. All right, so I'm just going to write out my truth table right here. Now, we know the truth table for P implies Q. It's only false when the antecedent is true, but the conclusion is false. So in other words, it's just this row right here. The antecedent is true, but the conclusion is false. Therefore, the conditional statement is false. And tell you what, just for fun, I'll write out Q and P again. Okay, but I'm going to do it in this order. Okay, so now the reason I wrote Q and P again is so that I have my two premises here together in two columns. And this is my conclusion here in the last column. Okay, now we have to focus on the rows where both of the premises are true. So let me highlight those rows where both of the premises are true. Okay, so you can see that's the case in this first row. So I'm going to kind of box that like this. Okay, now here both premises are false, so that's a no. Here they're both true, so I'm going to highlight that. And here I have one of each. Okay, so that's out. Remember, both of the premises have to be true for us to be using this in our check. Now you'll notice here the conclusion is true, but down here the conclusion is false. So that implies that this is not a valid argument. Okay, so notice, it's not that the conclusion is always true. Okay, that would basically never be the case. All right, it's that if the premises are true, then the conclusion has to be true for your argument to be valid. If your premises are true and your conclusion is false, then your argument is not valid. Okay, so if both of these were T's right here, my argument would have been valid. If I have even just one false in the column for the conclusion, where you're looking at the highlighted rows, then your argument is invalid. Okay, let's look at one more example. Okay, so another argument here. The premises are P or not Q, Q, therefore not P. So I'll start making my truth table here. So P or not Q. All right, now here I'm going to do something a little bit different than I did last time. True, true, false, false, not Q. False, true, false, true. Okay, so to get this column, I just copied the values that I had in this column here. To get this column, I took the opposite of the values from the Q column. And now I'm going to apply the OR operator. Now remember, the OR operator is true when at least one of the parts is true. Okay, so you'll notice here, neither of the parts is true, so the OR is going to return a false. But in all the other rows, I've got at least one true. So that's kind of the answer. That's the truth value for P or not Q. The truth value is in that column. Okay, so these columns right here, these are my premises. Now I need to look at the conclusion, which was P, therefore P. So true, true, false, and false. All right, now, once again, we need to look at the rows where both of the premises are true. And you'll see in this first row, I've got both premises true. Okay, and you remember, when I'm looking at the first premise, P or not Q, I'm looking at this column. So they're both true right there. And that's the only row where they're both true. So if the premises are true, the conclusion is true. So the conclusion is true in all highlighted rows. Okay, so this is a valid argument. All right, that is a valid argument. And we can determine this using a truth table. So you write out the truth tables for the premises and the conclusion. Highlight the rows where all premises are true. Now in this case it was just one row. In the previous case we saw it was two rows. It could be even more. Okay, but you're highlighting the rows where all the premises are true. So we've got two premises and we're highlighting the rows where both of the premises are true. And then we're looking at the conclusion. And when you're done highlighting your rows, you got to check, is the conclusion true in all the highlighted rows? If that's the case, your argument is valid. If you have even one false in one of the highlighted rows, then your argument is not valid.